Hello everybody again, welcome back. This is sections 4.3 and 4.4 in your textbook, logarithmic functions. A logarithm is an exponent. I'll be saying that over and over and over again. A logarithm is an exponent. It's a way to express exponents. So here's how it starts. If you have a base raised to some power equals x, well, that's what we're interested in. That's what the logarithm is. This means y is log base b of x. A logarithm is an exponent. It's just an exponent. Well, it's a way to express exponents. The exponent is now the logarithm in the variable. So here, when I work with logarithms, I always have to start here. Log base 2 of 8. That's what I remember. And then, what is that? What is this? That means this is 3, since 2 to the third equals 8. How about log base 10? Log base 10 of, 10,000 is what? 5, I guess? Because 10 to the fifth is 10,000. And so that's the way logarithms work. Seriously, it's just the exponent. It's a way to make arithmetic a lot simpler. That's how they were invented, by the way. We'll talk about that. So here's a formal definition. And it's going to look a lot like this board. Definition. F, y equal 4. Okay, well, there's a couple of restrictions. 4, x greater than 0. I'm going to talk about that. B greater than 0, and b not equal to 1. 1 would be trivial and redundant. Then this y equals log base b of x means, this is a definition, it means that b raised to the y power is x. You say to yourself, b to what power? That's the variable. 2 to what power is 8? 10 to what power is 10,000? Well, 5. That's what logarithms are. Logarithm is an exponent. That's the thing you're looking for. So we're at definition, and we read this as log base b of x. Log base b of x. That's how it's read. Log base b of x. Again, what that means is b to the, that's what we're looking for, is x. Log base b of y is the exponent, where y is the exponent that b is raised to, that the base b is raised to in order to get x. That base b is raised, to which base b is raised, sorry about the grammar area, is raised to get x. Is raised to get x. I'm going to have to do that differently tomorrow in class. And so there's a formal definition of logarithms. It truly is an invention that makes arithmetic a lot easier. Because, again, here's a single digit as opposed to a 5-digit number. So here's how it works. I guess we'll just do some little conversions, a couple examples, such as these ones we just did. Oops. How about log base 6? Now, nobody ever does base 6, by the way. The square root of 6 is a half. And, so that's a statement. And you're saying, well, what does that mean? Well, all we're saying is that 6 to the 1/2 power is the square root of 6. That's how you would express that. 5 squared is 25. Now I have it in exponential form. That's an exponential equation. I want to put it in a logarithmic equation. Log base 5 of 25 is 2. A logarithm is an exponent. And so that's converting back and forth. Here's evaluation. And these have to be written exactly, otherwise you couldn't evaluate it. I'll have a y, log base 4 of 64. Log base 4 of 64 means 4 to what power is 64? Y is 3. Boom. And let's do this. Y is log base 3 of 181. 81st. Log base 3, put the 3 weight in there, of 181 means 3 to what power is 181st? That's negative 4. 3 to the negative 4 power is 181. So there's just a couple. I was going to talk about, whoops, that's going the wrong way. Yes, I'm going to talk about zeros. Maybe I should bring my over here. I guess I will. Excuse me a second. Let me get my notebook. Bring it over here. Somewhere along the line we got to talk about zero. Here we go. Just note, by the way. Note. This is impossible. Where is it? Oh yeah. Log base, any base at all, of 0. You know, we'll make it a base b. This is impossible. Since what we're talking about is b to the what power is 0. Well, b can't, you can't take a number, a positive number, or a negative number, and raise it to a power and get 0. So that's impossible. So essentially, the domain and range for logs and exponents are switched. Range for exponential functions, log functions, they're just switched because we're switching the variables. For exponential and logs is switch. So, so the domain for logs go from 0 to infinity, and you will see that when we start graphing. The range, is all reals. All the reals for the range of log functions. Got all that. We're on the next page. Common logs. Oh, common logs and natural logs. Here we're doing stuff. No, you'd really have to be in a specialty place to have a log base 6, or for that matter, a log base 5. There are two kind of logs we work with: common logs and natural logs. In mathematics, we work with natural logs. But let's just introduce the two. Common logs is base 10. Natural logs is base e. It's base 10. And it's because of our number system is a decimal number system. We have 10 fingers. And so the point is we don't write it. Log base 10 of x means, or we just is log. We don't write the 10 of x. It's common log. If the base is not written there, that means it's understood as being 10. So the log of, let's do this. The log of, say, 152 is, I don't know what it is, by the way, but the point is between 2 and 3. Since log of 100 is 2 and log of 1,000 is 3. Actually, it's even closer to 2. So you can check it out on the calculator. You have a common log button on your calculator. So do you have a natural log button. Natural log. From now on, that's where we're talking, at least when you go to calculus. Common logs, no, not really. Certainly other bases, no. But in calculus, certainly the natural log. And the natural log, if we would say y equals e to the x, that's the number e, which we talked about last time. This means log, let's write it down. Log base e of x is y, but we don't write that either. Log base e is written as ln. Check your calculators. There's a button on there, ln of x. That's a natural log. Hey, keep this in mind. Let's see, e to the first is 2.7, so the natural log of 2.71282 is e to the first, is 1. Because e to the first is 2.71282. Natural logs. Okay, let's talk a little bit about these graphs. Oh boy. Graphs. F of x equals e to the x. We did this before. Looks like this. F of x equals ln of x. Looks like this. They're inverses of one another. If I should put this graph, let's put this graph over here, it would look like so. Oops, it would look like sorry. It would look like so, and there happens to be a line y equals x. Because we just switched the variables. The two functions are inverses because we just switched the variables. So this is an exponential function, that's a log function. Characteristics, this is 1 to 1. The domain of a log function is from 0 to infinity. The domain, all the x's, you can't pass that. You can't pass it because 0, you raise something to some power to get 0, you can't. The range, of course, is reals. And the x-intercept, this is the x-intercept, 1, 0. Notice over here the y-intercept was 0, 1. Again, we're just interchanging variables with the two graphs. And you can translate these things the same way. This is quick translation. Let's do this. From y equals log base b of x to y equals, let's see, a log base b of x plus c plus d, something like that. D is the horizontal translation. C is the vertical, horizontal. C is vertical translation. A is the stretcher or compressor, just like in exponential functions, like we talked about the last tape. And then if you put a negative here, y equals opposite of log base b to the x. It's an inverse. Or it reflects about the x-axis. It's a reflection. Okay. That's 2 sections. We are now at 4-1, 4-2, 4-3, 4-4 for this week, and we're keeping it, and we'll see you next time. Thank you.